Welcome to Battery Operated Systems for Community Outreach, Bosco, Uganda.
There, my name is Ethan Moses, and I work with Bosco Uganda again. Today we'll be doing a demonstration of how we wire our solar panels, and as you can see, I'm at one of the tower sites, purely powered by solar energy that we use. On this tower site, we have several equipment. We have switches. We power different ubiquity radios on the tower, as you can see. But today I'll be specifically focusing on the power part and then the demonstration of it. As you can see, we have a metal rack which we use to house all our different equipments. This can be got locally from your welder. Your local welder can have a design and he fixes you one of these. Yes. So this houses our batteries. It houses our charge controller and then the inverter if need be. Yeah. So I'll take you through a tour of what we basically do here for the final process. Yes. So I have solar panels here, 2 of them. I'd also love to say this, that in case you want to do the actual installation, you will have to have solar mounts. Could be either ground or roof mounts. But at Bosco here, we really recommend having a design for the mounts that are installed on the tower right above, for obvious reasons of security and access, to avoid access from animals and all other things around. So you contact your local welder and he can create for you a solar mount. Okay, these are solar panels rated 80 watts each. So we connected these in parallel. So a parallel connection, basically you have the positive of one joining the positive and the negative joining the negative. If you'd want a series, that would be you join the negative and positive of one side. So here, as you can see, we have our positive joining the positive of this panel, then the negative also joining, right? Then we have a long cable that extends and brings that supply, right? So here we have our digital multimeter that we use to test if we have the right connection or if supply is reaching our cable. So here you have the positive. You join the positive and then the negative. So you have about 18.9 volts. Okay. Also, this shows that you have a parallel connection, because in the parallel you maintain the voltage and we add the current, right? So we have it right. Yes. Here also we have a few lead acid batteries. You can also get these from your local supplier depending on the type you want. So here we have 2 batteries. We're going to try and connect them and see what we want to do. So like I said earlier on, if you connect them in series, that means you want to increase the voltage, and then parallel you want to increase the capacity of the battery, right? So we have our batteries here are rated 200 Ah. So if you wanted 400 to increase on your capacity, you would have to connect them in series. So what we do here, basically, you have your cable. So you have your cables, and basing on what you want to do, or the capacity, or the rating of your solar panels or your system, you would have to size the correct cable diameter, right? There are several ways you could do that. You could get resources online and calculate so that you use the right amount of cable. As you can see, these are different diameters. Okay, these are all used differently depending on the size of your system. Okay, you could have cables go as 50 millimeters or 2.5 smallest, depending. You really need to know the right amount of cable to use. So here we start our process is start with we strip our cable, and then we have what we call lugs. Right, strip about 2 centimeters long. Then this cable lugs still can be got, and then you just do this, right? Then it is hammered down. Use a hammer and you bounce it down for a full grips. So in case you want to have a series connection, this is what you do. This will be the negative and the positive of this. You'd simply do this. You could make this shorter. Just for demonstration, I decided to use this. Could be really shorter. You don't want some losses. You do some losses with the shorter cable. So you do this. Make sure you have a firm grip. Okay, so here now, simple as this, you have a series connection. Okay, so to confirm that, you will use your digital multimeter. So these batteries are rated 12 volts each, so that means you need about 24 volts. Okay, so you'd have the positive, and the negative, right, to test. So you'd have about 24 volts, right? Cool. Your next step would be you'd create another lug, right? So you would have this joining. You'd create 2 cables, the positive and the negative. Okay. Please note that there are color codes for different cables, depending on the region you come from or your locality. But for DC, most times the negative is for the black, right? And then the red is for the positive. It's important to use the correct color codes of the different cables. So right here, next we have our charge controller. We'll be using a Stecker. There's several brands in the market. So the charge controller basically regulates the amount of charge entering the battery. You don't want to overcharge or undercharge your battery, right? So this is why we have this. So always after you have your battery connections, always start the charge controller has several connections to the panel, and then the battery, and then DC load. But before you connect the panel, always start connecting the batteries. So these two cables here, they're quite long, but they don't have to be really long. So you have the negative and then the positive. Then right here, I don't know if you could zoom in, you have a port, or I'll call it a port, whatever it is. So this would join, would go to the negative side, then you would join positive side too, clearly labeled in the controller. So by now you should be having light to show you that you have a connection. I think the sun, you can't really zoom in on the light. So this is the battery first. So when you start with that, then you have your cable coming from the panel, right? It has the positive and then the negative side. So the negative will enter right here, then the positive too. Okay. So depending on the charge controller you're using, there should be a display already showing you that your charge controller is charging your batteries. So the charge controller also has a side for the DC load. Just in case you have equipment that use DC side, you could as well connect them here, right? Other than having an inverter, you just have a direct DC line from here, so you can power your equipment. But just in case you have an AC equipment that you need powered on, you'd have an inverter. You're using this is a Vitron rated about 180 watts. Again, you'd still have to size your equipment and know the right one to buy. So basically an inverter would convert the DC to AC. The pure sine and then the other. This is a pure sine wave. So as you can see, it has a DC side and then the AC side. Okay, so the DC side, the positive and then the black, you'll connect it. If you've plugged it well, you connect it to the negative or the positive side of the battery. Okay, then your output, you'd have to get your output, which will be AC, right from here. Okay, so then you could power on your equipment or your house, right, depending on what you want to use. Well, yes, that was a simple demonstration again, basically what we do or how we install. But again, solar is quite dynamic. Sometimes you might not have a charge controller depending on what you want, but what we had demonstrated here are the basics to have you started and install any of these at your community networks or your homes. It should be enough. But again, you should check with your local authority, because these installations could be dangerous if you're not really certified and skillfully trained in it. So safety first. And from here at Bosco, we hope to see that other community networks too can transition to this, because we think that as the years go down, the cost per watt will reduce, and then the cost of storage will still reduce. So
you have cheaper and more reliable renewable source of energy for your sites, right? So essentially you'll also be doing the environment a big favor with less emissions. Thank you. See you in the next video.